This is a presentation for the paper, A Postcard from Your Food Journey in the Past, promoting self-reflection on social food posting, authored by Zhida, Sitong Wang, Wenjie Onur Yürüten, Chuhan and Xiaojuan. The work is mainly done at the Hong Kong University of Science and Technology. My name is Zhida, and I will be presenting this paper on behalf of my co-authors. Social media nowadays has become a prevalent way for people to communicate mundane details of their daily lives, especially for posts on dining experiences. There are terms created to describe such a worldwide phenomenon, like camera is first or foodstagramming. To many people who frequently publish food posts online, social food posting is not only a means of self-representation, but also a way to implicitly track their health conditions. Despite the richness of information and data embedded in food posts, existing social media platforms do not sufficiently support users in directly using original food posts for a retrospective reflection of their physical and mental statuses. On the one hand, a systematic food logging procedure tends to be repetitive and tedious, which may not suit a highly experiential moment like food posting. On the other hand, existing design with exact values usually evokes judgment. Such conventional design may miss the cues for reflection on experiential aspects. To address these challenges, we explore how to support users' self-reflection on their physical health and mental well-being with social media food posts in this work. Our goal is to find an auto-transcription method to ease the tracking process and engage the self-reflection process with a proper design. Inspired by previous work on automatic data summarization and designs for data remediation, we propose a pipeline to automatically compose a postcard design visual summarization based on food post data. The pipeline first collects the image, text, and metadata from the original posts as input, then transforms information into related nutrition, emotion, and contextual information in the information extraction module. Next, the postcard composition module composes a postcard with a non-judgmental design based on the processed results. The pipeline takes the final postcard design as the output. I will explain in more detail about these two modules in the following slides. In the information extraction module, we extract the nutrition information from the posted images based on the recognized dish by borrowing the method from Facebook's Immense Cooking and the nutrition details from the official USDA National Nutrient Database. We used 5 major nutrition details for visualization. For the emotional information, we adopted a meta-learning approach in emotion distribution learning to make full use of a small training sample. The method accepts the food post message as input and predicts distributions for Ekman's 6 basic emotions at each time. We applied the most intense and dominant emotion for each food post. After obtaining all the information, we designed the postcard's front side with a non-judgmental visual design to encode the nutritional and emotional information, and the back side to show the contextual information. For the front side design, we aim to design a casual visual representation that achieves the following goals. The design should be informative and expressive. The encoding should enable clear associations. The visual layout should be balanced, and there should be no ambiguity. To find a suitable encoding scheme and design style, we recruited 6 university students with design backgrounds to brainstorm the encoding details in a 1-hour workshop. Participants provided interesting design templates during the workshop, and they arrived at an encoding scheme to represent the emotion and nutrition information with a metaphorical landscape design. To validate the encoding scheme proposed in the design workshop, we conducted an Inlab user study. We aim to verify whether the encoding scheme is intuitive enough for users to learn and whether users can get a consistent interpretation of the trends based on our visual design. We recruited another 10 participants from a local university through word of mouth. In the first study, participants all found the emotion encoding scheme is easy to understand. Even though some of them had difficulty in understanding the carbohydrates and protein in nutrition encoding scheme at first, they all accepted the encoding and agreed that the mapping made sense after our explanation. In addition, the results of our second study indicate that our design is capable of maintaining good consistency among different persons in visualizing both nutrition and emotional patterns. We designed the backside with contextual information and a legend. We arrange all the content by taking the traditional postcard backside design as an example. For the message content, we identify a common postcard message template from the internet, which includes one greeting sentence, the main body of users' posts, and one closing sentence with wishes to fill in the message area. When implementing our ideas, we adopted a template-based method leveraging real landscape photos to automatically compose the front side layout. We took the COCO dataset with segmentation labels and object localization information as a template. Then we mapped the collected visual elements to the corresponding target regions according to the geometric center of the segmented area. Finally, we adjusted the size and position of all the visual elements based on detailed design constraints. That is, we fine-tuned the design by following real-world common sense and using the geometric perspective. To fully understand how people interpret and respond to our postcard design, we conducted a 3-week study to collect users' posted data based on their real-life experiences. We recruited another batch of 20 participants from local universities through online advertisements and word of mouth, and collected participants' food posting data before, during, and after the exam week. Finally, we sent all sets of postcards to participants through email 3 months later, and invite them to hold an on-site or a phone interview to obtain their reflections. The final food post dataset contains 530 entries in total. Here, we show some of the postcards generated with our pipeline based on participants' food posting data. Our postcard design provoked a range of reflections in the study. Overall, all participants felt it was a nice surprise to receive the postcards. A lot of the participants explored the postcards by examining the detailed records and extracted information, identifying the patterns and trends, and exploring the relationships of the recorded data. They find the postcards help them understand the correlation between emotion and food choices, recall their previous eating habits and characteristics, and identify the similarity, the difference, and the trends in their food patterns. Participants also reflect the postcards in the light of the content of the food posts. They naturally start to recall and describe the things that happened at that moment. Some of them even recognize personal life routines by reflecting on the whole set of the postcards. Moreover, participants also motivated and developed actionable strategies, including changing their eating habits, sticking to their goals on a healthy diet, or even cultivating social relationships. Finally, participants rediscover personal values, characteristics, and attitudes, and revise previous personal expectations during the reflection. Some of them even think widely about their personal contributions to society. To conclude, I will leave you 3 takeaways. This paper explores how to support users' self-reflection on their food posts with an auto-generated postcard design. We present a way to treat historical posting data as a postcard, which boosts present and achieves effective self-reflection. Thanks for your attention. The full paper is available at the ACM Digital Library. If you have any comments or questions, please feel free to contact us.